If you've ever looked at your email's spam folder, you've probably noticed it successfully traps thousands of unwanted messages automatically. That sorting process isn't magic. It relies entirely on natural language processing, or NLP, to read and classify text. Over the course of this series, we are going to build a functional end-to-end spam classifier from scratch using Python. Here is a roadmap showing the 9 steps required to build this classifier. Today, we are focusing strictly on step 1, reading the raw data and formatting it properly so our machine learning model can actually process it. To follow along, you need 2 things: an open Jupyter Notebook environment and the messages.csv dataset downloaded to your local machine. The accuracy of any machine learning model is directly tied to how well the raw data is initially staged. If we feed the model unorganized text, it will give us unreliable predictions. Let's start coding. Before writing any core logic, we need to bring specialized external tools into our Python environment. First, type and run pip install nltk and pip install wordcloud. Running these commands explicitly right now prevents missing module errors later when we go to process our text. Next, we import pandas and numpy to handle numerical arrays. We also import matplotlib and seaborn for data visualizations, along with required scikit-learn modules that will eventually power our actual machine learning algorithm. Think of these libraries as the individual components of an engine. Without them properly installed and imported, our NLP pipeline simply cannot run. Now that NLTK is installed, we need to download specific corpora. Corpora are pre-built language databases that give our Python environment the baseline rules it needs to understand English. First, we use nltk.download to get the stopwords file. Stopwords are common filler words like the, and, or is. By removing them early on, we reduce the amount of text our computer has to process without losing the actual meaning of the email. We also download the WordNet database, which maps out semantic relationships and synonyms, and Punct, a tool that automatically tokenizes long paragraphs by splitting them into individual sentences. Execute this block. When the process finishes, you will see a list of Boolean true outputs, confirming that each database downloaded successfully to your machine. These downloads act as our algorithm's dictionary and grammar rulebook. Without them, the computer treats human language as a random, meaningless sequence of characters. Step 1 in the notebook is loading the raw data. Use the pandas readCSV function to pull your local messages.csv file into a data frame object. If you get a file not found error here, check your exact file path. The CSV must be in the directory you specify in the command. Running df.head visualizes the CSV structure. We see 3 columns: the subject, the message body, and a numerical label mapping normal emails to 0 and spam to 1. Checking isNull.sum reveals exactly 62 empty entries isolated within the subject column. Leave these rows exactly as they are. A missing subject line is normal in real-world emails, and it doesn't invalidate the actual message body, which holds the text we want to analyze. Checking the data shape and finding these empty cells now ensures our model won't crash when it hits an unexpected blank value during training. Before we train our classifier, we need to know the exact balance of normal emails versus spam across our 3,000 rows of data. We calculate this by taking the data frame's label column, applying the value counts method to tally the 0s and 1s, and wrapping it in a rounding function to output clean percentages. This donut chart shows our output. The dataset is comprised of exactly 83% legitimate emails and 17% spam. Knowing this baseline distribution confirms we have enough real-world examples of both categories to effectively train an algorithm to tell the difference. You have successfully configured your Python environment and downloaded all the necessary natural language toolkits. Your raw dataset is loaded, validated for missing values, and we've verified the exact distribution of spam to regular emails. In the next stage, we will start feature engineering. We'll write code to measure the length of every message and normalize all characters to lowercase so our model can process them uniformly. This organized data ingestion pipeline provides the exact foundation you need to build and train your final classifier.